Okay, good afternoon, all my geometry students, or good morning, whenever you're watching this. This is the Section 7 test review. I will send out a remind. I sent out a remind, obviously, to all the students to let you know this was posted, and it was posted on your OneView account under resources. So there will be some interruptions. They are cleaning my room right now, and I apologize for being sick, but here we go. So choose the correct justification to prove the two triangles below are similar. So some people have a hard time seeing these two triangles as similar. So what I did is I took this and I flipped it around so it's in the same orientation. And orientation means sitting in the same way or sitting in the same direction so that you can compare the similar sides. So I've gone ahead and done that. I've moved this around, and I'm going to go ahead and make sure I've labeled all the sides. So my base is 12, my hypotenuse is 20, and my height looks to be 16. Okay, a little squished in there. So 36 over 12, this reads 36 is proportional to 12, so 36 is proportional to 12, okay? That's an angle in there. And so 36 is proportional to 12, 60 is proportional to 20. All right, that would get 2 dots then. And then it says B, angle B, this one right here, is congruent to angle L. So it looks like I have side, angle, side, angle, side, similarity criterion. It meets the criteria for similarity. Next, I'm looking at 60 is proportional to 20. 60, my 2 dots, is proportional to 20. That's true. It has 2 dots. And 36 is proportional to 12. That's 1 dot to 1 dot. Good. And 48 is proportional to 16. This is 3 dots to 3 dots, which means that 60 divided by 20, 36 divided by 12, and 48 divided by 16 are all equal to 3. And so you can see that because all these proportions are equal, they are all equal to 3. And we know that we have a side, 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 which is corresponding to a side, side, side. So that would be side, side, side similarity criterion. Next, 48 is proportional to 20. Okay, 48 are triple dots is proportional to 20. No, 48 is proportional to 16. This is not right. So this is incorrect. So this is not similar. Next, 36 is proportional to 12. Single dot to single dot, and 16 is proportional to 48. Well, these sides are corresponding, but you cannot go from big to small and then small to big. So this is incorrect. It should have been 48 over 16. It does not matter about the angles anymore. This is not similar. Angle A and angle K are congruent. Let me switch colors. A and K are congruent. That's true. Those are my right angles, and a little hard to see. My right angles are congruent. Good. And then it says my C is the same as my L. Oh no, my C is not the same as L. C is the same as J. This is wrong. Okay, this is not similar. And B is congruent to L. We said that was true. And A is congruent to K. That is also true. So that gives us our angle-angle similarity. You'll notice this is a different version or the same version, but I spaced it out compared to what you got in class. So I want to give myself a little more room. Okay, number 2. This comes from a previous test. This is comparing two triangles. So we have two triangles here, and it says AD, so this length is 14. Not sure why that gave it to you, but it was already in the picture. What is the length of DC? So we're down here. We have a little question mark, a little baby area. What is this little teeny area here? We don't know. But we can find the distance of A to C the whole way, and then we can subtract 14 to find this little distance here. So sometimes you have a hard time seeing like this. I just wanted to redo it so that you could compare them side by side. We don't know the height here. That's X. But the bottom is 17. And so when we set up our proportions, we have X compares to 14. So X over 14 is equal to again, big over small, big over small. 17 over 12. Multiply both sides, by 14, by 14. Read my writing the right way. 14 cancels with 14. And I have to take out my calculator, show you guys. So, although it's a bit hard to read, that's the glare. Okay. So I have, let's see, I think I can put it here. So I have 17 times 14, 17 times 14 divided by 12. That's 19, so x equals 19, and they said round to the nearest tenth, 0.8. Done. Number 3, suppose you have two triangles. And I drew them out for you. So we have two triangles, so just we have two triangles, but I wanted to draw the scenario for you twice. So I have two triangles, and this is S-A-N and C-U-T. I think that helps to draw out two triangles. And then again, it's going to be the same thing, S-A-N-C-U-T. So this statement, so this is the given part of the statement is right here, okay? So the given part says that S-A-N and C-U-T we are given this information here. So S-A is proportional to C-U, that's the same here. And A-N is proportional to U-T. A-N is proportional to U-T. So I'm giving it, so it gave a single dot and then a double dot. So I need the same thing over here. Okay, so this is why I have two different versions. Timmy claims that proving that S is congruent to C will help him prove that S-A-N is similar, that says similar to C-U-T because of S-A-S. Is this S-A-S? No, it's not S-A-S because it's not the included angle. So Timmy is not correct. Sorry, Timmy. And then we need to look at Lexi's claim. So Lexi's claim is that, we're starting back from the very beginning, from the given information. Don't start from what we've gotten after Timmy has given us the information. We start from the given. So we're starting over again, and I've marked out my givens, and I have that Lexi claims that angle N is congruent to T. That looks good. And S is congruent to C. And I should double line that. So I have angle. So that's correct. That will help her prove that S-A-N and C-U-T are similar because of angle similarity criterion. So that means that Lexi is correct, and that cannot be true because because Lexi is correct. So it's B. Okay. Before rock climbing, Fernando, who is 4.8 feet tall, wants to know how high he will climb. Okay, so we're in a good shape here because this is all in feet. So it's 4.8. All right. And wants to know how high. Okay, he places a mirror on the ground, and he walks 7 feet back until he can see the top of the cliff in the mirror. If the mirror is 28 feet, so he measured how far the mirror was from the cliff. This is the cliff here. All right. So we want to know how high is the cliff, H. Okay, so we put H. So height relates to height of our Fernando, so 4.8. That's equal to so it's big over small, so 28 over 7. So multiply both sides by 4.8. Multiply by 4.8. That's multiplication. So I get my calculator, and I do 28 times 4.8, and I divide that by 7, and I get 19.2. 4.8's cancel out. So my height is 19.2 feet. And part 2 says determine the similarity theorem. This is side, angle, side, side, angle, side. It cannot be angle, angle because these angles, we don't know anything about these angles. These are not vertical angles because we don't have a cross of a line of two lines, or the intersection of two lines, so we're not sure. We don't know that it's angle, angle, and it cannot be side, side, side because all three sides aren't known. We don't know this side or this side. So it has to be side, angle, side. Similarity criterion. Okay, Thomas wants to measure the width of a pond, so he sets up triangles as shown in the diagram. He claims the two triangles are similar. Which similarity criterion enables him to make that claim? Well, we know that these are vertical angles, and so before we do anything, we know if this is a vertical angle that these are congruent. We have two right angles, right? Right angles are congruent. They're always congruent to each other. So we have angle, angle. This is angle, angle similarity criterion. And we want to know how wide is the pond. Okay, if you have a hard time seeing this, you can always flip this up, right, like this. And then you could see that this would be 120. And maybe it would be easier for you to compare the two triangles. I'm not sure. So we have, that was a little bit tall, but that's okay. All right, so I have x, so the height is to the height, so x over 120 is equal to the base 125 over the base of the small. So big over small, big over small. Okay, so multiply both sides by 120, and x equals 125 times 120 divided by 70 equals 214, and we'll do 0.3 feet. Use the information in the diagram to determine the height of the tree. This is probably the easiest question on the whole test. Notice that this is the mid-segment of the building. So this is half is high is the building. So this is 225 divided by 2, which equals 112.5, which is A. Again, there would be, this is 1/2 of this, or this is 2 times this. So okay, again, I spaced this out so it should look a little different than yours, just so I have my room. Find the length of the midsegment in the triangle to the left. The diagram is not to scale. This is just like our last problem. This, okay, 2 of these equals 1 of these. 2 of 4x plus 6 equals 6x plus 30. Or you can write 4x plus 6 equals 1/2 times 6x plus 30. Either way you want to do it. I'm going to show this one. So I'm going to distribute. I get 8x plus 12 equals 6x plus 30. I'm going to subtract 6x. I get 2x plus 12 equals 30. Subtract 12. And I get 2x equals 18. So x equals 9. Is that the answer to the question? No, they're not asking for x. They're asking for the mid-segment of the triangle to the left. That means you need to stick 9. You need to substitute 9 in for x here. So 4 times 9 plus 6 is equal to 36 plus 6 is equal to 42.